Imagine, if you will, a state-of-the-art billion-dollar skyscraper.
Yeah.
I mean, it's just an absolute architectural marvel.
Right. Gleaming glass, the whole 9 yards.
Exactly. The facade is gleaming glass. It has, the most advanced climate control algorithms.
Probably high-speed magnetic levitation elevators, some sustainable kinetic energy systems built right into the foundation.
Oh, absolutely. Everything you can imagine. So you're walking into this building to do your job, step into your corner office, and you're ready to work.
Okay, I'm picturing it.
But there is one fatal flaw in the design. To turn on the lights in your office, you have to find a specific physical key.
Wait, a key just for the lights?
Yeah, a physical key. Now, that key hasn't been given to you. Instead, it's been hidden somewhere inside, like one of the 50,000 random desk drawers scattered across the 80 floors of this building.
Oh, wow. I mean, that sounds like a surreal stress stream.
Right.
You have this incredibly expensive, highly capable structure that's designed to facilitate world-class work. But you are completely paralyzed by the most basic functional requirement imaginable, which is literally just finding the switch to let you see what you're doing.
Exactly. And you wouldn't blame the person for sitting in the dark, right? Like if you walked by and saw an executive just staring at a blank wall, you wouldn't call him lazy.
No, I mean, you'd blame the architect. You'd say, this is a catastrophic structural design failure. The building is fundamentally broken.
But here is the thing that we are going to explore today in this deep dive. And it's the thing that is honestly a little terrifying.
Terrifying is probably the right word for it, yeah.
We're doing this exact same thing every single day in the modern digital workplace. Welcome to our deep dive into the hidden enterprise search techs.
Yeah, so the mission today is to fundamentally reframe how you think about your company's data. And we are going to look at this through the lens of Dieter Rams.
Right, Dieter Rams.
For anyone unfamiliar with industrial design history, Rams is a legendary designer. He's most famous for his work at Braun, making those iconic radios and calculators.
The ones that basically inspired the whole look of the early Apple products, right?
Exactly, yeah. His core philosophy is less but better, or, good design is as little design as possible.
As little design as possible.
Right. And we are going to apply that absolute functional minimalism to your organization's data architecture today.
And the crazy part is, this isn't just like theoretical philosophy. We are looking at actual telemetry data and industry reports today.
Real hard numbers.
Yeah, from organizations like Slight, GoSearch, Agility Portal, and Bloomfire.
Yeah.
We also have these incredibly sharp, highly technical architectural manifestos from a systems engineer named Prasad Bond.
Those manifestos are incredible, by the way. Very dense, but brilliant.
Very dense. But when you put all of this together, a very clear picture emerges, which is that stripping away software bloat and focusing on raw data indexing can save mid-sized companies literal millions of dollars.
Millions. It changes the entire paradigm. So, as you are listening to this, I want you to consider your own day.
Yeah, think about your morning.
Have you ever spent an hour, maybe even just this morning, like you said, looking for a file you know exists?
Oh, I hate that feeling.
You know someone on your team created it. You know you saw it attached to a message last Tuesday.
Yep.
But you're checking Slack, you're digging through your email archives, you're clicking through endless nested folders in a shared cloud drive.
And it is just a ghost. Totally gone.
Exactly. It's a ghost.
I think everyone listening is nodding right now. I mean, it triggers this flash of personal frustration.
Yeah.
You literally start questioning your own memory.
You feel incompetent.
You really do.
Yeah.
But what these sources, particularly Bond's architectural breakdown, what they make crystal clear is that your inability to find that file is not a personal failing.
No, not at all. You are not disorganized.
Right. You are a victim of a structural collapse. Okay. We are funding massive engineering budgets, marketing budgets, operations.
Huge budgets.
Huge. But we are completely ignoring the mundane physical reality of file retrieval.
We treat data storage like a junk drawer.
Right.
Rather than a deliberately engineered library.
A junk drawer is the perfect way to put it.
And the friction you feel, it's the direct result of a system that was never designed for retrieval in the first place. I mean, it was only designed for creation.
Only designed for creation. So let's put some hard numbers to that friction. Because when you just say, people waste time looking for stuff, it sounds like a minor annoyance.
Like a paper cut.
Exactly, just a paper cut. But Bond calls this the enterprise search tax. And the math here is honestly sobering. The telemetry from Slight and the broader McKinsey data, it reveals that the average knowledge worker spends roughly 20% of their work week just searching for internal information.
20%. I mean, think about that.
20%. That means out of a standard 5-day week, an entire day is just vaporized.
Gone.
Gone. We are talking roughly 1.5 to 3.2 hours a day, every single day, just looking for things.
It is an invisible tax. And because it doesn't show up as a line item on a profit and loss statement, it goes completely unaudited by the finance department.
They don't even see it.
They have no idea. So let's do the granular math on this to truly grasp the scale of the failure. Let's say you operate a mid-sized enterprise, about 1,000 employees.
Okay, 1,000 employees.
We will use a very conservative estimate of a $50 per hour fully loaded cost for an employee. So that's factoring in salary, benefits, overhead, everything.
That's pretty conservative for tech or engineering, yeah.
Very conservative. If every single one of those 1,000 employees is delayed by a mere 30 minutes a day, not the high end of 3 hours, just a half-hour delay.
For 30 minutes.
That translates to a $6.25 million annual loss.
$6.25 million just evaporating into thin air.
Poof. Gone.
I mean, that is a massive chunk of operational capital bleeding out solely because highly paid professionals are clicking through folders looking for, like, PDFs, API specs, brand guidelines.
It's nuts. And the slight report actually aggregates this over the course of a year, and the perspective shifts from financial to temporal. When you add up those lost hours, the average worker is losing an entire month of work per year.
A whole month? Wait, so you're basically giving them a month of paid vacation to just search for files?
A full month where zero value is created. If you manage a 50-person team, the math dictates that you are essentially paying 4 full-time employees their entire annual salary to sit in a room and do absolutely nothing but search for knowledge the company has already paid to generate.
Okay, I have to push back on this a little bit.
Sure, go ahead.
Because is it really fair to call that wasted time? I mean, isn't searching just part of the job? Let's use a physical analogy.
Okay, let's hear it.
If you are master chef in a Michelin-starred restaurant, you have to take time to walk across the kitchen, right? You have to find the specific paring knife you need, locate the right copper pan, gather your ingredients from the walk-in fridge. You don't just magically have the tools manifest in your hand. Navigating your environment and finding your tools is the prerequisite to doing the work.
Right. Well, the culinary world actually provides the perfect counterargument to that exact mindset.
Really? How so?
And it ties directly back to Dieter Rams' design philosophy. A master chef does not hide their knives in random drawers before the dinner rush.
Okay, that's fair.
They do not put the salt in the basement and the pepper in the attic. A professional kitchen operates on the principle of mise en place.
Everything in its place.
Exactly. The environment is ruthlessly designed for functional clarity and immediate, predictable retrieval. The tools are visible, they're accessible, and they're organized by workflow.
Okay, so the friction isn't the act of reaching for the tool, it's the fact that the tool's location is a complete mystery.
Yes. The problem in the digital workplace is the complete absence of mise en place. We are hiring senior, highly specialized professionals.
Right, people making big salaries.
People whose core competency is like mapping complex neural networks, designing thermodynamics for hardware, or architecting global supply chains. And we are forcing them to act as digital archaeologists.
Digital archaeologists. That is such a visceral image.
We are making them excavate corporate ruins just to piece together the fragments of a project. I mean, that is a failure of architectural design, not an inevitable reality of doing business.
Sweeping away the dirt to find the crucial email from 2023. So, as a listener, run this calculation for your own team right now. How many hours a week are you paying your top talent, your lead developers, your creative directors to dig through endless Slack channels from 6 months ago?
And the tragedy here is that teams have normalized this archaeological dig. It has become culturally embedded.
It's just how things are done.
Right. When a project manager builds out a timeline in Jira or Asana, they implicitly know that finding the historical documentation or getting access to the right repositories is going to take a week. So they just build a delay buffer into the sprint. We have essentially accepted structural rot as standard operating procedure.
You just hit on something crucial there, the delay buffer. Because when we talk about a $6.25 million loss, that's just the raw payroll cost of the clock ticking, right?
Exactly.
But if I'm a developer waiting on a file, I don't just sit there staring at my monitor for an hour. I shift to another task.
Yeah.
So isn't the real cost much deeper than just the minutes lost?
Oh, absolutely. Let's get into the actual physics of this workflow blockage, because Prasad Bond details some incredible examples in his manifestos that make this really tangible.
Yeah, break down the physics for me.
The deeper cost is the complete loss of momentum and the destruction of cognitive flow. Vond explores the scenario of the asynchronous workflow stall, which is, increasingly common in distributed, remote-first companies.
Right, everybody's spread out.
Imagine a back-end developer working in Tokyo. They're in the zone, deep in a state of flow, writing complex code. Suddenly, they hit a broken microservice. They know the documentation explaining how this microservice interacts with the broader database exists.
Right, they remember a meeting about it a year ago. According to the sources, let's say that documentation is buried in an unnamed Notion page owned by a product manager located in Toronto.
Exactly. So the Tokyo developer searches their local drive. Nothing. They search the main engineering wiki. Nothing.
They search their chat history.
Nothing. Finally, they realize they have to request access or send a direct message to the Toronto product manager. But because of the geographical distribution, there is a 12-hour time zone differential.
So the Toronto product manager is asleep.
Fast asleep.
So the Tokyo developer is just hard stopped. The required asset is locked behind a human gateway who won't be online for half a day.
The assembly line waits. Software velocity flatlines. And that 12-hour stall is not just a loss of a few minutes on a timesheet. The developer now has to perform a massive context switch.
Which is brutal on the brain.
Completely brutal. They have to package up their current mental model of the code, save their progress, abandon the microservice, and try to pick up a completely different, unrelated ticket just to stay busy.
And then, when that Toronto PM finally wakes up, finds the link and sends it back to Tokyo, the Tokyo developer has to spend an hour just refamiliarizing themselves with what they were doing the day before. The friction compounds.
It compounds massively. There's another example from the industrial sector in the sources that illustrates how this transcends software and impacts physical manufacturing.
Oh, this was fascinating. Let's talk about the hardware example.
Imagine a mid-sized hardware operation. A tooling supplier based in Munich needs a specific tolerance specification from a design lead in Tokyo to begin machining a physical part.
Right.
The file they need is literally named heatsink v4 final.step.
We have all encountered a file named exactly like that. The pure desperation of trying to denote the final version without any actual version control software.
Exactly. So in the scenario, that specific CAD file doesn't live in a centralized, managed product lifecycle management system. It lives in an unnamed, localized desktop folder on the Tokyo designer's laptop.
Just sitting on their hard drive?
It isn't indexed globally at all, so the Munich supplier hits a wall and sends an email asking for the file. The 12-hour time zone delay kicks in again, but in this hardware scenario, it's not just code velocity that stalls, it is a physical assembly line.
Heavy machinery is literally sitting idle on a factory floor.
The financial physics of that delay are astronomical. You have factory overhead, delayed shipping schedules, downstream bottlenecks, all triggering because a single CAD file was stored locally rather than globally indexed.
So what happens to the human beings trapped in these broken architectures? Because people aren't stupid, right? They adapt to their environments, even hostile ones.
They do.
The sources discuss a psychological symptom of this, a phenomenon they call search anxiety. Let's break down what that actually looks like in a worker's daily life.
Search anxiety is a highly rational adaptation to a dysfunctional digital environment. When employees repeatedly lose faith in the central corporate repository,
They know it's garbage.
right, when experience teaches them that searching the company intranet is just a futile, time-wasting exercise, they develop hoarding behaviors.
Hoarding.
To protect themselves from future stalls, they start downloading critical PDFs, architectural diagrams, CAD models directly to their own local hard drives.
They create their own private shadow silos. Which, makes sense from an individual survival standpoint. I don't trust the library, so I'm stealing the book and keeping it under my mattress.
Exactly.
But organizationally, that creates a whole new nightmare. Now you have 50 people working off 50 slightly different, outdated, localized versions of the same master document.
The version control completely shatters, but the telemetry data reveals an even more alarming behavioral adaptation.
What's that?
According to the reports, roughly 11% of all failed internal searches result in employees simply giving up and recreating the assets entirely from scratch.
Wait, I need to make sure I understand that. 11% of the time, they don't ask a colleague, they don't keep looking, they just rebuild the thing from the ground up.
Yes. The friction of the search becomes greater than the friction of creation. So the Tokyo developer gives up on the sleeping Toronto PM and simply writes new code to bypass the undocumented microservice, adding massive technical debt to the code base.
No, man.
Or the designer in Tokyo, unable to find the actually final .step file, just opens their software and redraws the CAD model from memory.
It's the equivalent of reinventing the wheel every single Tuesday, simply because you misplaced the blueprint for the wheel on Monday.
It's a staggering waste.
The sheer waste of human potential and creative energy is just, it's staggering. If you are listening to this, you have almost certainly witnessed this behavior. You have probably participated in it. You save a crucial Q3 strategy presentation to your own desktop, completely isolated from your team's shared drive, just so you don't have to fight the company search bar when the CEO asks for it next week.
It is a universal coping mechanism. And when the C-suite or the executives finally notice this friction, when they finally see the localized hoarding, the version control disasters, and the delayed timelines, their instinctual response is almost universally counterproductive.
Let me guess. They buy another piece of software.
Exactly.
They purchase a massive, expensive new productivity dashboard that promises to, unify the workspace.
That is the standard executive playbook, and it brings us right back to the core philosophy of Dieter Rams.
Less but better.
Right. The executive logic is usually driven by departmental ego and isolated procurement budgets. The sales leadership insists their team must live entirely within Salesforce, so they buy auxiliary tools specifically for the Salesforce ecosystem.
Right, because that's what sales knows.
Engineering camps out in GitHub and Jira. The design department demands Figma and its associated plugins. Operations runs their entire universe through Slack. Every department buys a highly specialized software as a service, or SaaS, tool to solve a localized workflow problem.
Okay, let me play devil's advocate here for a second.
Go for it.
Because if I'm the VP of design, I absolutely want my team using Figma. If all these departments are buying tools that are explicitly designed to work best for their specific jobs, shouldn't we let them?
Absolutely.
I mean, a UI designer shouldn't be forced to use a clunky general-purpose spreadsheet tool to mock up a website. If we let Figma, GitHub, and Salesforce all exist, aren't we just giving people the best tools for the job? Why is that a bad thing?
Providing specialized tools is not the problem at all. The UI designer absolutely must use Figma, and the backend developer must use GitHub. Rams wouldn't argue against specialized tools.
Okay, so where does the failure happen?
The failure point is not the tools themselves, it is the interface friction between those isolated tools. The issue arises when the executive team recognizes that sales can't see what engineering is doing, and their solution is to buy yet another overarching dashboard software to sit on top of everything.
So they try to build a bridge by just adding another island.
That's a great way to put it. By purchasing another layer of software to fix the communication gap, they are violently violating Dieter Rams' principle of reduction. They are not stripping away design. They are adding another silo, another layer of administrative overhead, another user interface, and another password people have to manage.
They are compounding the fragmentation. You just told me these silos are destroying the company, and the solution to the silos is to build a master silo.
Exactly.
How does adding a search dashboard magically solve the fact that the sales director literally does not have the login credentials or the license to open the engineering team's GitHub repository?
It doesn't, and that is the crucial distinction Bond makes in his architectural breakdown. Companies do not have a tooling shortage. They have a severe data linking deficit.
A data linking deficit.
True architectural repair does not require a new visual dashboard. It requires pure underlying indexing. We have to strip away the user interface bloat entirely and focus on the raw mechanics of the data itself.
So we have to treat internal data retrieval with the exact same rigid parameter engineering and latency standards that we apply to customer-facing web applications.
Precisely. We optimize our public websites flawlessly, but our internal tools are a mess.
Okay, this is where we need to transition from diagnosing the disease to actually explaining the cure. Let's unpack this concept of pure indexing and architectural repair.
Let's do it.
If I'm an IT director for a 1,000-person enterprise, what are the actual mechanics of this? How do I fix the data linking deficit without just buying more software licenses?
To understand the mechanical fix, we have to look under the hood of how modern enterprise search operates at a database level. The Bloomfire report provides a very clear breakdown of this architecture.
Okay, lay it out for us.
To unify these fragmented repositories to bridge Jira, Slack, Google Drive, and Salesforce, you do not migrate the files. You do not force the engineers to move their documentation out of GitHub and into a central wiki. You leave the data exactly where it lives.
You leave it alone.
Yes. Instead, you deploy a unified search API.
Okay, let's break down what that API actually is for someone who isn't a systems architect. An API, an application programming interface, is essentially a digital messenger, right?
Think of it as a standardized diplomatic protocol between different software nations. You build a central search engine, and you send out these API messengers to all the different departments.
Okay, so the messenger goes out.
The API goes into Slack, reads a conversation thread, extracts the text, and brings it back. It goes into Google Drive, opens the PDF, reads the contents, and brings it back.
Got it.
It forces all these disconnected proprietary systems to report their contents into a single queryable master index without ever moving the original files.
And once all that raw data is pulled back into the central brain, how is it organized? Because, I mean, dumping a million Slack messages and 1,000 CAD files into a bucket doesn't make it searchable. It just makes a bigger junk drawer.
Right, a massive unsearchable junk drawer. Within that central brain, the enterprise search architecture typically constructs 3 highly specific layered indexes.
Okay, what's layer 1?
The first is the full text index. This is the brute force foundational layer. The system reads literally every single word in every single document, chat log, and wiki page and maps its exact location.
So if the word thermodynamics appears on page 42 of a PDF from 2021, the full text index records that coordinate.
Exact.
That makes sense. It's like the index at the back of a textbook. But the slight report highlights a really crazy performance gap here.
The 95% NES, 10% stat.
Yeah. When you or I search for something on Google Consumer Search, we find exactly what we want on the first page of results, roughly 95% of the time. But internal enterprise search, using full text indexing, has a first attempt success rate of only 10%.
That is a massive 9.5x performance gap.
Why are our internal corporate tools so vastly inferior to public search engines?
It comes down to the underlying structure of the data itself. The public internet has a massive amount of invisible structure baked into its architecture.
Like what?
You have hyperlinks connecting related pages, you have SEO metadata tags deliberately authored by webmasters, and you have Google's PageRank algorithms analyzing how many people click on a specific link to determine its value. The internet is highly structured.
But internal corporate data is just wild.
Internal corporate data is fundamentally unstructured. It is a chaotic swamp of raw text, fragmented chat logs, abandoned draft folders, and randomly named files like our friend heatsink v4 final.step.
Right.
A full text index alone cannot make sense of that swamp. That is why the enterprise system must build the second layer, the structured index. This relies on automated metadata extraction.
How does metadata extraction artificially inject structure into that chaos?
The system algorithms analyze a raw document and automatically generate tags. It looks at a completely unformatted text file and deduces. Based on the author, the file path, and the timestamps, this is a hardware specification file created by the Tokyo design team last Tuesday, and it is related to Project X. It builds a rigid, structured lattice around the unstructured data, allowing you to filter a search not just by the word heatsink, but by heatsinks created by Tokyo in the last 30 days.
Okay, so we have the full text index doing the brute force word mapping and the structured index categorizing the metadata. What is the third layer of the index?
The third layer is the semantic index, and this is where machine learning and AI begin to elevate the architecture. A semantic index maps meaning, intent, and conceptual relationships, rather than just exact character strings.
Give me a concrete example of how that bridges a gap that the first two indexes would miss.
Sure. Imagine you search the company portal for the phrase Q3 revenue. A full text index will only look for documents containing those exact words.
Right.
But what if the finance department published their report under the title Third Quarter Financials? The exact word revenue isn't in the title and Q3 isn't spelled out. A basic full text search completely fails.
Because it's too literal.
Exactly. But a semantic index understands the conceptual proximity. It knows that Q3 means third quarter, and it understands that revenue is highly correlated with financials. It connects the underlying concepts, retrieving the correct document regardless of the specific vocabulary used by the author.
That is incredibly powerful. But this brings up a massive, glaring issue.
The elephant in the room.
The elephant in the room. If we deploy this unified API, and it successfully scrapes everything from private Slack channels to the HR portal to the executive Jira board, and it builds this godlike semantic index, We have to talk about security,
Yes, we do. It is the single biggest roadblock to implementation.
because this sounds like an absolute nightmare for a chief information security officer. If the system links absolutely everything, how do we stop a junior marketing intern from typing payroll into the search bar and accidentally pulling up the CEO's compensation package?
Or a list of employees slated for layoffs.
Exactly.
Yeah.
Or the company's unannounced merger plans.
This is the critical juncture where we have to dive into the technical difference between early binding and late binding in search architecture. How a system handles permissions dictates whether it is a secure enterprise tool or a massive liability.
Okay, let's unpack these two models. What happens in a late binding architecture?
In a late binding system, when that junior marketing intern types payroll, the search engine executes the query across the entire unfiltered index.
Everything.
Everything. It finds every single document that matches the word payroll, including the highly confidential executive spreadsheets. It gathers all those results together. Then, right at the very last millisecond, right before it renders the results on the user's screen,
It checks the rules.
yes, the system checks the intern's Active Directory permissions and frantically filters out all the restricted documents they aren't supposed to see.
I want to use a physical analogy here to see if I grasp this. It's like having a bouncer for a restricted library, but the bouncer is stationed at the checkout desk at the very back of the building. The intern walks into the library, roams the aisles freely, grabs a highly classified book on executive salaries, and walks up to a reading table. And right as they sit down to open it, the librarian pops out from behind a desk, checks their ID, realizes they don't have clearance, and violently snatches the book out of their hands before they could read the first page.
That is a brilliant way to visualize it. The system allows the retrieval to happen computationally and only blocks the display.
That seems risky.
The risk with late binding is twofold. First, there is a massive latency cost. The system is burning computational power, pulling up thousands of restricted files that will never be shown. Second, it is a massive security vulnerability.
How so?
If there's a glitch in the UI rendering layer, or if a savvy user intercepts the data packet before the final filter is applied, you have a catastrophic data leak.
The book is in their hands,
Yeah.
even if it's just for a second. So I assume early binding puts the bouncer somewhere else.
Early binding is the gold standard for enterprise security architecture. In an early binding model, the user's access permissions and security clearance are mathematically injected into the search query itself before it ever touches the index.
So the bouncer is checking your ID at the front doors of the building.
Exactly. When the intern searches for payroll, the system doesn't just search payroll, it searches payroll plus user clearance level 1. Because the confidential documents are tagged with clearance level 5, the search engine simply bypasses them. To the intern's search query, those restricted books do not even exist.
They aren't even visible on the shelves.
The system doesn't waste milliseconds retrieving them, and there's zero risk of UI leakage because the restricted data was never pulled from the database in the first place.
That is incredibly elegant. But wait, corporate permissions change constantly, right? People get promoted, they move teams, they get fired. How does a search engine know who has clearance on any given Tuesday?
This requires document-level security synchronization. The enterprise search platform must continuously sync with the company's Active Directory or Okta identity provider. Leading platforms refresh these permissions anywhere from every 24 hours down to near real-time, depending on the API rate limits.
Okay, that makes sense.
Furthermore, you must ensure the platform adheres to a zero data retention or ZDR policy.
Zero data retention, meaning the search company itself isn't hoarding our secrets.
Correct. ZDR means that the third-party search provider's AI models are not training their public algorithms on your proprietary corporate data. It also means they are not creating permanent, localized copies of your files on their own external servers. They are simply federating the search in real time, mapping the index, and passing the data through without holding on to it.
Okay, so let's summarize the architecture. We have the data linked via API messengers. We have the full text, structured, and semantic indexes built. We have the early binding bouncer at the front door, ensuring military-grade security.
Right, all the structural pieces are in place.
But here's the kicker. None of the structural repair matters if the system is slow. And this is where Prasad Band's engineering manifestos get incredibly prescriptive, almost dogmatic. He introduces a metric called the 200 millisecond latency standard.
This is where we see pure Dieter Rams' philosophy directly applied to software engineering. Bond doesn't offer a suggestion. He states a rigid, uncompromising parameter engineering rule.
A hard rule.
A search query for any internal corporate documentation must return a verified, accurate result in under 200 milliseconds. Not a second, not 3 seconds of a spinning loading wheel. 200 milliseconds.
I'll have to ask about the specificity of that number. Why 200 milliseconds? I mean, that is a fifth of a second. It is literally the duration of a human blink. Why is a fifth of a second the hard line between architectural success and structural failure?
Because 200 milliseconds is not an arbitrary software goal. It is a hard mechanical constraint tied directly to human neurobiology and psychology. It relates to what UX designers call the Doherty threshold.
The Doherty threshold.
Right. If a digital interaction, clicking a button, typing a query, takes longer than roughly 400 milliseconds, the human brain perceives it as a delay. You become consciously aware that you are interacting with an external, sluggish machine. You realize you are waiting on the software to compute.
It breaks the illusion of control.
Exactly. But if the system's response happens in under 200 milliseconds, the delay falls below the threshold of conscious perception. The software ceases to feel like a clunky tool you are operating, and instead it feels like a seamless extension of your own cognitive process.
That is a profound psychological distinction. It's the difference between driving a cheap car with a loose steering column, where you turn the wheel and then wait a beat for the tires to respond,
Where you feel mechanics.
versus driving a perfectly tuned Formula One car where the vehicle just moves simultaneously with your physical intent.
And we have to extrapolate how that speed fundamentally changes human behavior at scale across a 1,000-person enterprise. Consider the behavioral economics of the office. If a worker knows from experience that searching the corporate wiki is going to take 5 or 10 seconds of loading, spinning wheels, and navigating a clunky user interface, they simply won't do it. The perceived friction is too high.
They will default to what seems like the path of least resistance.
Which is to interrupt a colleague. They will open Slack, find the Toronto product manager, and type, "Hey, quick question, where is that file?"
Which creates the quick question paradox that the Slate report warns about. Because a quick question is never actually quick.
The irony is brutal. By avoiding a 5-second search delay, the searcher interrupts the answerer. The answerer has to break their own cognitive flow, switch contexts, find the file, and send it back. Now both individuals have lost their momentum.
The company is effectively paying twice the hourly rate for the exact same piece of information.
However, if the search latency is reduced to 200 milliseconds, the path of least resistance flips.
Because at 200 milliseconds, it is physically faster to just hit Command F and search the global index than it is to type the phrase, "Hey, quick question," into Slack. Speed doesn't just save time, it alters the behavioral culture of the company. It eliminates the interruption economy.
Changes everything.
But let me challenge the feasibility of this. Is 200 milliseconds actually achievable in the real world?
What is?
I mean, if we're talking about an enterprise with 1,000 employees, they are carrying decades of legacy corporate data. They have massive gigabyte-sized CAD files, millions of lines of historical JIRA tickets, and endless gigabytes of Slack conversations. Can a system truly query all that historical weight in a fifth of a second?
It is achievable, but only if you strictly adhere to Bond's mandate of pure raw data indexing. You will absolutely fail to hit 200 milliseconds if your architecture forces the search query to load the heavy visual user interface layers of the individual SaaS applications.
Explain what you mean by loading the visual layer.
If your search tool has to wake up the Salesforce application, load the Salesforce visual formatting, pull the data into a graphical dashboard, and render it with corporate logos and drop-down menus, it will take 3 seconds.
Way past the threshold.
You cannot hit the threshold if you carry the UI baggage. You have to bypass the visual interface completely. You federate the search directly into the raw database layer via the API, and you return plain, unformatted text. Pure function, zero ornamentation.
It is the ultimate expression of less but better.
Exactly.
Okay, this brings us to what I consider the most exciting, actionable part of this entire deep dive, the 48-hour protocol. Because it's easy for us to sit in a studio and philosophize about latency thresholds and API messengers.
Right.
But if I am a mid-level engineering manager or an IT director listening to this...
How do you actually do it?
Exactly. How do I actually execute this? How do I prove this works without spending 8 months in procurement meetings evaluating a $75 per user enterprise contract?
You don't ask for a budget. You don't pitch a software migration. You prove the underlying physics first. Bond outlines a strategy he calls the 48-hour actionable validation signal.
48 hours.
The premise is ruthlessly pragmatic. Do not spend millions trying to build the entire steel suspension bridge. First, just throw a simple rope across the canyon to prove that the two sides can theoretically be connected.
I love that. Prove the physics of the connection before you build the infrastructure.
Yeah.
So walk me through the exact mechanical steps of this protocol. If I am an engineer listening right now and I want to start this tomorrow morning, what do I do?
Step 1. You write a completely lightweight Python script. We are talking 50 to 100 lines of code at maximum. Nothing heavy, no complex frameworks.
Keep it incredibly simple. Step 2.
Step 2. You target a specific, highly painful data bottleneck. You do not try to index the entire company. You go to the engineering department, and you use standard REST APIs to extract just the 50 most frequently accessed Confluence wiki pages or the 50 most active Jira bug tickets. You pull that specific data out of the silo.
What does that data look like when the Python script pulls it out? Is it a visual page?
No, it is a raw JSON payload. JSON JavaScript object notation is just a highly structured format for storing text data. It looks like a list of attributes. Title, bug 404, author, Dave, status, open.
So you have these 50 raw JSON payloads. What is step 3?
Step 3, you dump those raw payloads or even just the direct file paths into a bare bones, locally hosted Elasticsearch instance. Elasticsearch is an open source, highly optimized search engine designed specifically for blazing fast text retrieval.
Okay, Elasticsearch.
Or if you want to be truly minimalist and prove the concept with zero infrastructure, you can literally append all that text into a single unformatted .txt file stored on the local network.
Wait, just a literal notepad text file. Peter Rams would be weeping tears of joy.
It is the absolute essence of reduction. Step 4, you build a completely naked, unstyled HTML text input box that connects to the Elasticsearch instance. Or if you are using the single text file, you just rely on the user opening the file and hitting Ctrl+F on their keyboard.
So no design at all.
The visual presentation is entirely irrelevant. The only strict non-negotiable parameter for this test is that the data retrieval must happen in under 200 milliseconds.
So we have built the rope across the canyon. It is ugly. It has no branding, no nice CSS colors, no drop-down menus. It is just a raw, brutal, lightning-fast text box. What is the final step? How do we use this to bypass the bureaucracy?
The final step is what Bond calls the binary test. You take this ugly, perfectly functional HTML search bar, and you walk it over to the desk of the Tokyo engineering lead or the chief operating officer.
The person feeling the pain.
The specific executive who is feeling the agonizing pain of those 12-hour time zone stalls. You put it in front of them, have them type a query, and you ask one binary question. Does this instantaneous retrieval eliminate your 12-hour workflow stall?
If they type heatsink v4 and the exact file path instantly materializes on the screen in a fraction of a second.
The answer will invariably be yes.
Yeah.
And the moment the answer is yes, the corporate conversation changes entirely. You are no longer an IT manager begging the CFO for a budget to buy a speculative productivity tool.
Right.
You have empirically, mathematically proven that you can eliminate a massive multi-million-dollar operational choke point using basic open source data linking. At that point, the executive mandate flips.
You're not asking permission anymore.
You are ordered to scale the cross-platform API indexing across the rest of the organization. The physics work, now you just scale the engineering.
That is such a subversive, powerful way to hack corporate bureaucracy. Show, don't tell, prove the physics, then ask for the budget.
Exactly.
So let's play this out. The COO is blown away. The 50-line Python script worked perfectly. Now the company has approved the project and is ready to actually scale this architectural repair to all 1,000 employees.
Right.
How do we unify a modern enterprise without it devolving back into chaos a month later?
We have to contextualize this transition by looking at the broader market reality. According to the Slate survey data, the corporate world is currently sitting at a massive tipping point. Roughly 73% of companies do not currently have a unified enterprise search architecture.
73%, that's almost everyone.
They are still operating in the digital dark ages of localized desktop folders and endless Slack scrolling. But the 27% of companies that have crossed the threshold and implemented this indexing are seeing asymmetric, almost unbelievable efficiency gains.
The report highlights a specific case study, right? Agorapulse.
Yes, Agorapulse implemented a unified architecture, and they tracked the internal telemetry. They successfully cut their internal information requests by 90%.
90%. I want you, the listener, to just pause and imagine your daily work life if 90% of the, hey, do you have a second? Messages, the where's the roadmap, emails, and the can you grant me access, notifications were completely eradicated.
It would feel like a revolution in personal focus.
It really would. But achieving that 90% reduction at an enterprise scale requires more than just Python scripts and APIs, doesn't it?
Definitely. A script proves the concept, but managing the collective knowledge of 1,000 dynamic human beings requires governance. You cannot solve a human behavioral problem purely with code.
Okay, so what's the missing piece?
This is where the emerging role of the knowledge manager becomes a critical necessity for any large organization.
That makes total sense because if you just use an API to index a massive swamp of outdated garbage, you aren't fixing the problem. You are just enabling people to search through garbage 9.5 times faster.
Precisely. A high-speed index of terrible data is still terrible data. The knowledge manager is a dedicated role or an entire team that provides three vital ongoing functions to maintain the architecture: control, context, and chemistry.
Let's break those down. What does control look like in a digital library?
Control is the active curation of the information flow. It means establishing strict naming conventions across all departments. It means ruthlessly archiving obsolete files, deprecating old code documentation, and ensuring that when someone searches for the Q3 strategy, only the actual final version is indexed, not the 6 drafts that preceded it.
It is the janitorial work of keeping the index pristine.
Yes.
And context.
Context means acting as a digital information architect. It is about understanding the relationships between different silos. A knowledge manager helps map the semantic index we discussed earlier, ensuring that a sales enablement document is structurally linked to the engineering product roadmap, so that a salesperson searching for a feature update understands the technical constraints behind it.
And the third function, chemistry. That sounds a bit esoteric for data management.
It is the most human element of the three. Chemistry is about bridging the cultural divides between departmental silos. It is about establishing a shared corporate vocabulary.
Give me an example of that.
If the engineering department tags their releases as a deployment, but the marketing team searches for the term launch, the system will fail unless a human being maps those concepts together. The knowledge manager builds the chemical bonds between the different dialects spoken within the company.
So as a listener, how do you diagnose your own organization? How do you know if your company is merely annoyed or if it is at the absolute breaking point and desperately needs this architectural repair?
The reports synthesize the telemetry into 5 major warning signs of structural collapse. Let's run through them.
Yes, listener, challenge yourself. Do you recognize these symptoms in your own daily stand-ups?
Warning sign number 1. Teams are asking the exact same questions repeatedly. If you see the identical "how do I request PTO?", "where is the high-res brand logo?" or "what is the Wi-Fi password for the guest network?" question pop up in a general Slack channel every 3 weeks, your retrieval system is broken.
Warning sign number 2. Shadow documents are multiplying like a virus across personal drives. You look in a folder and you see strategy Q3 final.pdf, strategy Q3 real final.pdf, strategy Q3 usetsis and dave.pdf, the loss of a single source of truth.
Warning sign number 3. Constant daily interruptions for document locations. We discussed the behavioral economics of this, the death of momentum and cognitive flow via the quick question paradox.
Warning sign number 4. Information is wildly scattered across tools, and departments view each other with suspicion. Marketing is confident the truth lives in Google Drive. Sales swears the accurate data is in Seismic, and neither side trusts the other's reporting.
And finally, warning sign number 5, which is perhaps the most damaging to long-term morale. Employees are hoarding files locally out of search anxiety. They have completely lost faith in the organization's technological competency, and they are retreating into individual survival mode.
It is a grim picture when you list them all out like that. But the solution we have explored today is so clear, so functionally elegant, if leaders are willing to strip away the bloat. We have covered a massive amount of ground today. Let's do a quick recap of the journey we've taken through this architecture.
We started by quantifying the invisible hemorrhage, the $6.25 million enterprise search tax that quietly drains mid-sized companies when highly paid workers lose 20% of their week just looking for standard files. We examined the physics of the 12-hour asynchronous workflow stall, where a missing Notion page or an unindexed CAD file completely halts production and shatters cognitive momentum across global time zones.
We rejected the standard executive reflex of buying yet another bloated SaaS dashboard, and instead applied Dieter Rams' philosophy of functional minimalism to the digital workplace. We looked at the raw mechanics of API integration, metadata extraction to structure the unstructured swamp, and the absolute necessity of early binding security to protect the organization from catastrophic data leaks.
We established Prasad Bandey's strict standard, the 200 millisecond latency threshold, rooted in the Doherty threshold of human perception, which is required to make a digital tool feel like a seamless extension of the human brain rather than a clunky external machine. And finally, we walk through the mechanics of the 48-hour protocol using a 50-line Python script, JSON payloads, and an Elasticsearch instance to mathematically prove the physics of data retrieval before spending a single dime on enterprise contracts.
It is entirely about stripping away the interface, ignoring the departmental egos, and respecting the raw data. That is the blueprint for stopping the hemorrhage. But before we sign off, I want to leave you with one final mind-expanding thought to chew on. We've spent this entire deep dive analyzing how to build a system that finds things perfectly and instantly. But if you look at the trajectory of the tech industry, the technology is already moving past mere retrieval.
That's moving toward action.
Exactly. Imagine a world where you don't even search at all. If we successfully index all enterprise data so perfectly and map the semantic relationship so tightly, what happens when autonomous AI agents stop waiting for us to type a query and start proactively acting on the data?
It changes everything.
Picture that Tokyo developer again. They were typing code about to make a specific architectural error on a microservice. They don't even know they're stuck yet. But the AI agent, constantly scanning the semantic index in the background, notices that their keystrokes match a failure pattern that the Toronto team resolved 3 years ago. Before the developer even hits compile, the agent quietly surfaces the Toronto team solution directly into their screen. The system anticipates the blockage before the human even perceives the friction. But you can't build a proactive nervous system on scattered, hoarded desktop folders. First, you have to index the raw data.
You have to lay the foundation.
That's our deep dive for today. Look at your own digital architecture this week. Ask yourself, are you building mise en place, or are you forcing your best talent to be digital archaeologists? Until next time.